Hello everyone. So today we will discuss about the transformation of coordinate system. That means we already know about the rectangular coordinate system that we have studied in the CHS also. That is the vector from in the XY coordinate, and the R is the position. And that rectangular coordinate will transfer to the polar coordinate. And what is the polar coordinate? That is in R and theta term. So today we will discuss this topic. If you like the previous video, then please share and subscribe it, and also comment if there are any mistake. So please subscribe this channel and also share it so that it will be helpful to others. Okay, so what is the rectangular coordinate system? So this is the rectangular coordinate system. That is, we have two axes, one is x and another is your y axis, and if a point is there, we can represent it as the point xy, right? So this is the rectangular coordinate system, and the position vector is the origin to O. So this is the position vector that we represented as R vector. Okay, so R vector is the position vector and dr by dt is the velocity vector. But remember one thing, that these things, that is the coordinate system, if we transfer to polar coordinate system, then how it will look like. So this is the polar coordinate system. So if we will change this, so that will give you the polar coordinate system. So polar means there is a angle theta, but this theta angle is changing. Remember, theta is the angle with theta is that angle that the position vector is making with the x-axis. Okay, so this one is theta. So theta कौन सा एंगल है? नो, जो पोजिशन वेक्टर है वो x एक्सिस के साथ जितना एंगल बना रहा है वही है थीटा. So theta is the angle of the position vector with the horizontal axis. So this, remember, here R is constant. That means this is a circular coordinate system. So the R here is constant, but the theta is changing. So what's happening when t equal to 0? Suppose when t equal to 0, we are here, and when t equal to 1, we are here. When t equal to 2, we are here, right? So on the time interval, the theta is changing. That means theta is a function of time. So what we got? The theta is a function of time. Okay, so look to the second case. So in the second case, what happening? Look this case. In this case, so the R also changing, right? So it is moving in different orbit. So if you look that it is rotating in different orbit. So what happening in this case? So okay, here in this case the radius is constant and this is a circle. So the circular coordinate system also a polar coordinate system, but here R is constant. But same thing here is there, but here R also a function of t, right? So theta is a function of t, R also a function of t, and in our polar coordinate system we will use both R and theta as a time variable. R also depending upon time and theta also depending upon time. Suppose you are started from here, then after 5 minutes or 10 minutes, कुछ समय के बाद आप कहाँ पर होगे? यहाँ पर होगे. सो यहाँ से फिर यहाँ पर, फिर यहाँ पर, फिर यहाँ पर. ऐसे हमारा सैटेलाइट भी रोटेट करता है. मतलब अब हमें अर्थ का कुछ संकेत जानने के लिए भी जो सैटेलाइट भेजते हैं वो भी ऐसे ऑर्बिटल पाथ में रोटेट करता है. मतलब उसका रेडियस और जो थीटा है वो वेरिएबल है, वो टाइम के ऊपर डिपेंड करता है. सो इसलिए हमें ये जानना बहुत जरूरी है. सो व्हाई वी नो दिस पोलर कोऑर्डिनेट सिस्टम? Okay, so to know the path of the orbital motion, that means how the satellite is rotating, how is the path, or how one is moving along a center fixed. So to know about these things, we have to know this polar coordinate system, so that it will be helpful for you to understand the classical mechanics, the quantum mechanics and everything. So this is one important part of mathematical physics. So let's transfer the rectangular coordinate system to polar coordinate system. But one more important thing, we have rectangular coordinate system, then why we are transferring to polar coordinate system? Okay, so we will study that, then you will understand why we will use polar coordinate system. Because remember, polar coordinate system is easy to find out the area cross section, the volume cross section, and the position, the velocity and acceleration. So actually this is one is more complicated. but the polar coordinate system is more easy, so that we can easily evaluate the area of a rectangle or the area of a circle. How we will find the area of the circle? We know pi r square is the area of the circle, but how we will find? If you know the polar coordinate system, then you can easily find out what is the coordinate transformation. Okay, so let's transfer the coordinate system. So what's happening here? If you look that this one, if you look this, okay, I am removing now this part. So we will draw the practical graph. So what's happening if we do the mathematical graph? So this one is our r radius, right? So this one is theta, and this one is your x, and this one is your y, right? And one point is the xy. Okay, so let's write more clearly about that so that you will understand. That means we have two axes. One point P point is there which have xy, right? So the central distance, that is the distance from the center, is the radius. Okay, that radius may be different. That means it may be depend upon the time. But we are discussing the general constant, the general case. That means r is a function of t, and theta also another function of t. So both are time dependent. Okay, r depend upon time, theta also depend upon time. So what's happening? What is the meaning of p of xy? Suppose this is a path. Okay, so suppose this is a circular path. This may be circular or may be elliptical. So what is the x? What is the x value? X is nothing but the distance from the y-axis. What is x? X is the distance from the y-axis. So this one is x, right? And if we compare this one is our x. Then what is y? Y is the distance from the x-axis. So this one is y. So now you look to the triangle OAP. So what's happened in the triangle OAP? So this is the transformation. Okay. This is the transformation. Then how we will transfer? So remember here in the triangle OP, so your cos theta is nothing but x by r, right? So what is x? X is nothing but r cos theta. Then what is sin theta? Sin theta is nothing but y by r. So what is y? Y is nothing but r sin. Remember, this one y means this one also y, right? This one y means this one also y, because this is the same. This is a rectangular. So this is y, this is y. Okay, you can denote another point here. So this is the Q point. So this is the rectangular OAPQ. OQ equal to AP, right? OQ equal to AP, and your OA is nothing but equal to PQ. So this point is Q. Okay. So this is the transformation, that how we transfer this r and theta. Okay. So what is r? R is nothing but x square plus y square, and its root over. So this is one transformation of your rectangular coordinate system to polar coordinate system. And what is theta? Theta is nothing but tan inverse y by x. So if a point in rectangular coordinate system is given to you, then how you find the r theta value? A point in rectangular coordinate system is given to you. How will you find the r theta? So r is the x square plus y square root over, and theta is nothing but tan inverse y by x. So this is the transformation to polar coordinate system. Okay. So now what is our position? So what will be the position? So the position now, remember what is position vector? X I cap plus y j cap. And this is we call the displacement also, because this is the distance from to origin. So okay, so now what we got? So x is cos theta. Remember, this is the magnitude. This is the vector cos theta I cap plus r sin theta j cap. Right? So we can write it as r cos theta and r sin theta. So this is the position coordinate system. So remember that this is our x component and this is our y component. But remember, still now we not completed, because there is I cap and there is j cap. What is I cap, J cap? I cap, J cap are unit vectors in our rectangular coordinate system. We have to transfer this I cap and J cap to polar coordinate system. So that is our next task. Okay. So this is the displacement. Then we will find out the velocity. Then all our thing. Then what is the scale factor? That's the other thing. Now we will go to the parameterization. Since we are discussing the polar coordinate system, that is the plane polar coordinate system, so we have to know about that. So this is the position. Remember, this is the position. Actually, this coordinate system, this is two-dimensional, right? When the plane plane is 2D. That's why this is two-dimensional. And later in the next class we will discuss about the 3D, that we call the curvilinear coordinate system. This is plane polar coordinate system. Then that one, the 3D part, is a curvilinear coordinate system, that is cylindrical, spherical. So we will go slowly. Okay. So now let's look the parameterization of circle. Remember, in the parameterization, if it is one dimensional, the parameterization is one dimensional, so take the r as constant, right? So take the r as constant. So what will be a position vector? That will be r cos theta. But remember, theta is a function of time. So, and that one is the r sin theta. But how is the theta vary, right? So we are doing the parameterization for a circle one. So what's happening in the circle? So look to your parameterization. Because the parameterization, why we need the parameterization? This is the circle one. For circle, why we need this? Because this will helpful to find out the work done, the energy for. Because force into displacement is the work done. So when the displacement is changing in a circular manner, so we need this parameterization, right? Remember, here r is constant because this is a circle, so radius is constant, but the theta is changing. So what will be happen when t equal to 0? When t equal to 0, our position is equal to nothing but, so here put, so that will be r and that will be 0. So r0. What is R0? So this is the first quadrant, we know this, and this is the second quadrant, this is third quadrant, and this is fourth quadrant. In first quadrant, both x and y are positive. In second quadrant, x is negative, y is positive, right? And in third quadrant, both x and y are negative. And in the fourth quadrant, our x is positive and y is negative. So this is the quadrant system. Okay, we already know this. So what's happening to R0? Remember, this is the radius, so this one also radius. So this point is the R0 because the y coordinate in the x-axis is 0. So this is the R0. Now look what is, so we are moving to upward, right? We are started here from t equal to 0. Now we are going to t equal to pi by 2 second because pi by 2 is easy to handle this trigonometry, right? So what will be the position? The cos theta is nothing but 0 and this is r. So what is 0 r? So this point is 0, right? So this one is 0. So how you are moving like? So you are moving like anti-clockwise. So that means you are moving like anti-clockwise. So this is your theta equal to 0. Okay? So so this is actually theta, right? Because theta is a function of time. So if we take the time, that will represent as theta. Okay? So when theta equal to 0, we have such a time. Actually, this is theta. So theta equal to 0 and theta equal to pi by 2. This is one time t1 and this is another time t2. So at the time t1, theta equal to 0 and we are at the position r0. Then at time t2, theta equal to pi by 2. That means in our watch, if we started at 12 p.m., that means from here we have started the car. You are moving, what the vehicle you have, maybe scooter or car, anything. So when you are started, so you look to your watch, that means you are started from 12 p.m. So after t1 time, that is after 1 p.m. maybe. So you are at the position theta equal to pi by 2. So similar case. So this is the 2 time interval. So when t1 theta equal to 0, when t2 theta equal to pi by 2. And look to the position. So this is the, we know that this is 0, this is pi by 2, this is pi, this is 3 pi by 2. So if we parameterize in the form of the circle, if we parameterize the position, this is nothing but the x and this is the y. So if we take x equal to r cos theta, y equal to r sin theta, why I have taken like this? Because our equation of circle is nothing but r square equal to x square plus y square. हमारा जो सर्कल का इक्वेशन है वो है r square equal to x square plus y square. So you do x square plus y square, that will give you r square. So that's why I have taken like this. But remember, you can take this as r sin theta and this one as r cos theta also. That will give you the direction only. That means that will change the direction. If this is moving like anti-clockwise, then that will move like clockwise. So this is the parameterization for anti-clockwise sense. Remember. So this is the parameterization for anti-clockwise sense. Okay. So this is anti-clockwise. Remember. So this parameterization of position will give you anti-clockwise sense. Then how you will use this parameterization? So why we need this? Because suppose when you are calculating the line integral, I have made some videos on the line integral, surface integral and volume integral also. You can go through it, then you will understand why we need this parameterization. Okay, so to find out the work done, okay, then the line element. So these are all things where we need, but because remember dr is nothing but this is dx I cap plus dy j cap. So this is the line element. Okay, so that's why we need the parameterization. Then you parameterize dx and dy, then transform the ij into the polar coordinate system. So this is the all about clockwise sense. Then next we will see how the parameterization changing in anti-clockwise sense. Okay, so now if the circle that is moving in the clockwise sense, that means you look to your watch. So how is the watch moving? That means it is 12 to 3, then 6 to 9, then to 12 again. So in this case, if your circle, that means the coordinate system is moving in your clockwise sense. So this is moving in your clockwise sense and this is the radius. And we know that this is first quadrant and this one is your second, this one is your third quadrant and this one is your fourth quadrant. So what is this value? This is your r. So what will be the coordinate system here? That means what will be the point? Here x is r and y is 0. In the next case, so here this is the y-axis, right? So this is x-axis and this is y-axis. So this is r. That means the y coordinate is r and x is 0. So x is 0, y is 0. In the second case, so this one is plus plus and this one, here x is minus and y is plus. And what is third quadrant? In third quadrant all are negative. And in fourth quadrant x is positive, y is negative. Therefore, this one is your minus r and your x is 0. And again if you go to this, so this one is r and it's 0. So what is this value? This value is your x is 0 but y is minus r, right? So these are the coordinate points if you are moving to in clockwise sense. Then for this case, what will be your parameterization? That means what will be your polar coordinate system? So remember, this is the circular coordinate system. That means your polar coordinate system, but this is generally called as plane polar coordinate system because we are using two-dimensional. So what's happening here? So here will be your that means your r is constant because we are taking a single circle. We are not changing the r value. We are changing the theta value, right? That means the time is changing. So when t equal to 0, you are here. When you are 0, when t equal to 5 minutes, then you are here. So this is the polar coordinate system. But in the circular parameterization, your r is fixed. So how you are moving? When t equal to 0, you are here or you are here, then you are moving to here, then you are moving to here, then you are moving to here. So you are not moving in a linear path. You are moving in a circular path. So if your position you are started from here, then you will go to here, then you will go to here because we are going in a clockwise sense. So in the anti-clockwise sense, we have seen the parameterization, how we parameterize it. But in circular case, that means in clockwise sense. So for clockwise path, your r will be what? That will be sine theta I cap into cos theta, plus cos theta j cap. Or that can be also written as your So this is sin theta I cap, that can be also represented as sin t into cos t. So the t and theta both are similar here. Due to the notification, these are changing. But remember, with respect to time, your theta is only changing, and here r is fixed. So this is also a polar coordinate system, but this is moving in a circular path only. That means these are not moving like this one. So here r is fixed, right? So look, when t equal to 0, what will be your position? If t equal to 0, your position will be, you substitute t equal to 0, that means 0, sorry, this is r cos theta and this one is r sin theta, and then is okay, right again. So this is r sin theta and this is r cos theta. So this is your r sin t and this one is your r cos t, right? Because we are I forgot about to write the r value, because the radius also is there, but radius is constant. That means if you given circle equation x square plus y square equal to 9, then your radius will be 3. So here when r equal to, that means t equal to 0, so here r x coordinate is 0 and y coordinate is r. That means 0 r. So this is your first point. So this is the first position. When t equal to pi by 2, what will happen? That means this is your second position. So your second position will be, this is r and 0. So this is your second position, r0. So this is the second, so this is the third, this is the fourth. How we will find the third? You put t equal to 3 pi by 2, then your position will be 0 minus r. Okay, sorry, that is 3 pi by, sorry, so this is pi. Okay, so this is pi. Then you will got cos pi is minus, so that will be you got, and your fourth coordinate is your t equal to 3 pi by 2. Then you will get the position as 3 pi by 2, that is minus r 0. So here how much your theta is changing? That is 0 to theta 2 pi. So this is the, remember, this is the transformation, that is the parameterization when you are moving in clockwise sense. But if you are moving in anti-clockwise sense, then the previous one will be the parameterization. So these are the two parameterization we are used in the polar coordinate system. So this is the circular case, right? Okay, so next we will go to our polar coordinate system. This is one transformation, there is one parameterization. Okay, so what is the position in our polar coordinate system? So we have a polar coordinate system, and here r and theta both are changing, right? So r and theta both are changing. That means if this is your x and y, and we have a point here p, and this one is xy, then what is x? What is x? So x is nothing but the distance from y. So the distance from y is your x, and the distance from x-axis is nothing but your y, right? And the theta is the angle with the x-axis. So remember, theta is the angle with x-axis. And what is the value of theta? That means limit. So the limit is 0 to 2 pi. So this is the coordinate system. And if you take the cosine value, cosine theta will be this one divided by your hypotenuse, then your hypotenuse, that means your, so this is your y and this one is your x. So you take the cos theta, you will get x value. Take the sin theta, you will get the y value. So what is the position? This is nothing but cos theta I cap into plus sin theta j cap. Remember, this bracket we use only to represent as cos theta I cap plus sin theta j cap. But remember, the coordinate system, that means the plane polar coordinate system, are still not clear. That means are still not complete, because here is I cap and j cap. So we have to transfer this I cap j cap to your polar coordinate unit vector. So next is the requirement of unit vector. Okay, and to know this unit vector, first of all we have to know the scale factor. Before know this unit vector, we want to need about the, that means we need the scale factor. So what are the scale factor? So the scale factor is nothing but h1, that is your del r divided by del r and its magnitude. So we have r vector. So again I forgot to write the r here. sorry, so your r vector is equal to r cos theta I cap, then that will be r sin theta j cap. That means your r sin theta. So one r will be there and one r will be there. So this is the position. So you take the partial derivative and you will obtain, this is nothing but cos theta into comma sin theta. And if you will do the magnitude, that means if you will find the magnitude, that will give you 1. And you do the h2, that means sometimes it is called as hr also, so and it is called as theta also. So that means this is the partial derivative with respect to r, so we call hr, and h theta is nothing but this is the partial derivative of theta, right? So you do the partial derivative, you will obtain minus r sin theta, then your r cos theta. So if you do the magnitude, that will give you r. So you do the partial derivative. If you don't know the partial derivative, then that is different. So you do the partial derivative. This is the partial derivative with respect to r, right? So do the partial derivative with respect to r. So here r will be cancelled due to this partial derivative, and here r is there because we are taking the partial derivative with respect to theta. So what is the derivative of cos theta? Minus sin theta. What is the derivative of sin theta? That is cos theta. R will be there because when we are doing the partial derivative, this is the variable and r is constant. But when doing the partial derivative, so here theta is constant. So you take the derivative, del r by del r, that is 1, del r by del r, that is 1, and cos theta sin theta will be there. So this is the scale factor. Okay. So what is the unit vector now? So remember, in the Cartesian coordinate system, that is when we are representing r as xi cap, yj cap, we have the unit vector x cap, which is nothing but I cap, and we have the unit vector y cap, which is nothing but the z cap, right? These are the representation only. So in similar, what is the unit vector in polar coordinate system? So that will be r cap and theta cap. So what is r cap? Remember the formula. This is nothing but del r by del r. Now we have calculated the partial derivative, right? So divided by h1. What is h1? This is nothing but del r by del r divided by 1, right? So you took the partial derivative, you will get cos theta I cap, sin theta j cap, right? So this is the unit vector r cap. Now we remove the diagram, that is not important now. So this is the r cap. Okay, so what is r cap? That is cos theta I cap plus sin theta j cap, right? Then you do the theta cap. So what will be the formula of theta cap? Now you can understand. So del r by del theta divided by h2. That means you took the partial derivative, you will obtain minus r sin theta and your r cos theta, that is divided by your h2 is nothing but r. So what is the theta cap? This is nothing but minus sin theta I cap plus cos theta j cap, right? So this is the theta cap. So what is theta cap? This is nothing but minus sin theta I cap cos theta j cap. So look here, what you obtain. So you obtain that. Okay, I am writing again. So this is the derivation of r cap and theta cap. You take the partial derivative, then divided with the scale factor, that will give you r theta. So what is r theta? Del r by del r divided by h1. What is theta cap? Del r by del theta divided by h2. And you know what is h1, h2. h1 is nothing but this one magnitude, and h2 is nothing but this one magnitude, right? So, okay, I am reviewing everything. Now we will transfer the coordinate system, that is we will transfer the unit vector. So we have to transfer the unit vector to find out the position vector perfectly in your polar coordinate system, because we didn't find still now the perfect coordinate system, that is the perfect transformation. So what we will obtain? So what is our position coordinate system? So the position is nothing but r vector equal to cos theta, in r cos theta I cap and r sin theta j cap, right? So this is the position vector. So what we obtained now, so we obtained also h1 was 1 and h2 also r. So this is the scale factor, and we got the r cap as cos theta I cap sin theta j cap, right? And we obtained the theta cap, that is minus sin theta, and this is cos theta. So this is the unit vector. So look here, there is nothing but your theta cap is nothing but d by d theta upon r cap. So this we obtained this one from this. So what is the r cap? So this one, and this is the theta cap. So we obtained already this using the scale factor. So the most important thing is your position vector. But why we need the r cap theta cap? What is r vector? R cos theta I cap, r sin theta j cap. But we know that r vector is a function of r and theta only. So we have to remove the I cap j cap. This is r cos theta I cap, na? Then r sin theta j cap. So we have to remove that I cap j cap. So we have to transfer. Okay, remember? So now we can write this as, so remove the bracket and use the I cap format. Okay, so remove the bracket here and write in I cap. So r cap equal to cos theta I cap plus sin theta j cap, and your theta cap is minus cos theta I cap, then your plus cos theta j cap. Okay, so now do the first one, do the first operation. What is the first operation? So give this is your first equation and this is second equation. Okay, so do the first operation, give it as a. So what we will do, we use the technique that to convert I cap to r cap and theta cap. So what is the technique? So first technique is that you multiply cos theta into r cap, then plus sin theta into theta cap. Do this. So what's happening? What is r cap? R cap is your cos theta I cap plus sin theta j cap. Multiply here cos theta. So what will happen? Cos square theta, right? Then multiply here sin theta. So what will be happen? So that will be your sin square theta. Okay, right? So you subtract both them. Then what you will obtain? You will obtain that your I cap. So this will nothing but your I cap, right? You do the operation multiply cos theta into r cap, then multiply here cos theta, that will be cos square theta, and here sin theta cos theta, then subtract, you will get I cap. And the next one is that you multiply sin theta into r cap plus cos theta into theta cap. So what you obtain? Look again, multiply sin theta into r cap and cos theta into theta cap. So what you will obtain? Now you will obtain j cap, because because we will use the technique that sin square theta plus cos square theta equal to 1. So this is the same thing here. I applied the trigonometry that if that is cos square theta and that is sin square theta, if again I subtract the both them, then the minus sign will be get plus sign. So cos square plus sin square theta, that will be 1, and here sin cos and here cosine, that will be subtract. In the second case, you add both them, first one will be cancelled and you will get second component. Okay, so this is all about the transformation. Here the I cap j cap transformation and here the r cap theta cap transformation. So try to remember these things, so that will be helpful for you, right? So next we will see about the position. Now the position what happening? So the position of what is r vector? So this is equal to r cos theta I cap, right? R cos theta I cap plus r sin theta j cap. Now you substitute here, so that will be r cos theta, and what is I cap? I cap will be cos theta I cap minus sin theta theta cap, right? Then again substitute plus r sin theta, and then substitute here your j cap, that is sin theta r cap plus cosine theta, theta cap. So this is the position vector in terms of r and theta only, right? So this is nothing but your position vector in terms of r and theta only. So this is the transformation of your position coordinate in Cartesian form to your polar form. This is the transformation, all total transformation in polar system. So now, so this is all about your position. Next we will go to the velocity form, right? So why we need the velocity? Because remember the r and theta are changing, right? The r and theta, if we are moving like this in polar coordinate system, then the r and theta at any time what's happening? Now the r also changing and the theta also changing. If this is the polar coordinate system, then your r is changing and theta also changing because this is rotating, right? If it is clockwise, then that will be different. That will be sine theta and that will be cos theta, that we previously discussed. And if it is anti-clockwise sense, then this is the format. Because when a particle is moving in the anti-clockwise sense, it will be positive z direction, and if it is moving in the clockwise sense, then it will be negative z direction. That means if it is moving anti-clockwise, then this is outward, and if it is moving clockwise, then this is inward. Okay. So next we will go to the velocity. So what will be the velocity? So we know that the velocity is nothing but dr by dt, right? So let's first write it is in the Cartesian form, then we will transfer to the polar form. Okay. So what is dr by dt? So that will be d by dt of, that is dr, that is r vector, that is r cos theta, then your r sin theta, right? So if you will do, remember r and theta both are variable, both are depending upon the time. So you have to take the derivative for both, that is uv. So apply the uv rule, then you will obtain, okay, so this is a one part and another part is the d by dt of r sin theta, right? So now you apply the uv rule and take the derivative with respect to t. Okay, so here we will use two new terms. What are the new terms? So remember the dot. If one dot is there, that is the first time derivative, and if theta dot is similarly, so that will be d theta by dt. So remember, these are the time derivative notification. If one dot is there, then that is first derivative. If two dot will be there, then that will be second derivative. Okay, if two dot is there, that will be second derivative. Now in the velocity, we need the first derivative. So that will be represented by r dot. Okay, so you do the derivative. What's happening here? So this is u and this one is v. This is u, v. Apply the uv rule. So what will be happening here? So first derivative into second one. Okay, then plus first one into second derivative, d by dt of cos theta, right? So the another also same thing, that will be r dot sin theta plus r into d by dt of sin theta. To do the derivative, I am just writing it. So what will be happening here? So that will be your minus, okay, so that will be r dot cos theta. You do the derivative, so and next one will be minus r sin theta into theta. And the second one will be what? The second one will be, so look here, so that will be r dot sin theta plus r cos theta, theta dot. Since there is no space, so I have not bracketed it. So you try to bracket this, because sin theta is one part and cos theta is another part. R and theta dot is different and r dot is different. Here theta dot also different. So you do the derivative, you will obtain this. You take first r derivative, that is r dot, then keep cos theta, because this is uv rule. Then you do the first one, then keep the first one, do the second derivative, d by dt of cos theta. What is d by dt of cos theta? That is minus sin theta into d theta by dt, because there is variable t and there is variable theta, both are different. So that's why I use the chain rule. Again here also same thing. So you do the first derivative, that is r dot sine theta plus r cos theta, theta dot. Okay, so this is the velocity component. But remember, what is this thing? This thing is nothing but your I cap into r dot cos theta minus r sine theta into theta dot. And the second component is nothing but plus j cap into r dot sine theta plus r cos theta into theta dot, right? So this is the velocity component. But remember, this is the velocity in your Cartesian coordinate system. So this is nothing but your, right? So this is a dx by dt I cap and a dy by dt j cap, because our r is nothing but x I cap y j cap. So you take the time derivative, that will be dx by dt dy by dt. Then this dx by dt is the first one and dy by dt is the second one, because x equal to r cos theta, y equal to r sin theta. But still now this is not in polar form. So how we will transfer the polar form? Look to the previous one. So substitute here I cap in terms of r cap and theta cap, and substitute here j cap in terms of r cap and theta cap. Then what you will obtain? You do the substitution, and what you will obtain, I am just writing it. So this is equation 3. Okay, substitute I cap j cap, substitute I cap and j cap from okay, in terms of r cap and theta cap. So you substitute the I cap and j cap in equation 3. You substitute I cap and j cap in terms of r cap and theta cap. Then what you will obtain the velocity, and you do simplify in equation 3 and simplify. You simplify it, you will obtain. So this is the task for you. You do the substitution and then simplify. You will obtain the velocity as, this is nothing but r dot r cap plus r theta dot theta cap. So this is the velocity in terms of polar form. Okay, so this is the velocity for plane polar coordinate system. So how you obtain this? You do the time derivative, then substitute the I cap j cap, you will obtain these things. So I have in general, what happened in general case? So in general, that means for any coordinate system, that may be 2D, that may be 3D, or any coordinate system, remember your V will be h1 r dot r cap plus h2 theta dot theta cap. And then again, if there, remember we are doing 2D, so what are variable? R and theta. Okay, so that is r dot r cap, theta dot theta cap. Just multiply r dot r cap into h1. What is h1 here? So h1 is 1 and h2 is r. We have previously discussed. So substitute here, that you will obtain this thing. When we will go to the curvilinear coordinate system, actually this plane polar coordinate system are two types. One is your 2D, another is your 3D. In the 2D, we discuss the plane polar coordinate system, and in the 3D, we will discuss the curvilinear coordinate system. In the curvilinear coordinate system, there are three components: r, theta, another will be phi or z. So these are the different things. Okay. So what I am telling now, this is polar coordinate system. One is your 2D, another is one is your 3D. So the 2D is nothing but the plane polar coordinate system, and the 3D is nothing but the curvilinear coordinate system. Okay, so this is the curvilinear, and the curvilinear has two parts. One is cylindrical part and another is your spherical. Okay, so this is the coordinate system, and in the spherical, so there are three coordinate system. So one is the plane polar coordinate system, that is your 2D, then the curvilinear, that is 3D, up to one is cylindrical and spherical. So this, since this is 3D, so it has three variable. One is r, another is theta, and another is z. R, theta, z. And in the spherical, that will be r, theta, and phi. So these are the coordinates. So then we have, so since this is cylindrical, actually 3D, we have I, j, and k. I cap, j cap, k cap, and here we have I cap, j cap. That we transfer to r theta. So the plane is your r theta, and your coplanar, that is r theta j. That means this I cap, j cap, k cap will transfer to r cap, theta cap, j cap, and in spherical r cap, theta cap, phi cap. So we will discuss the cylindrical part in your next class, right? So this is the velocity. So now you will obtain the acceleration. So this is acceleration one. I will give you the task. You do the acceleration, and I will tell you what is the answer for the acceleration in the next class. But I am giving you the hints how you find out the acceleration. So what is acceleration? Acceleration is nothing but that is your dv by dt, right? So what we obtain dv by dt? dv by dt, what we obtain? So remember, we obtain these things. That means our velocity are, what we obtain our velocity. So this is nothing but your r dot r cap plus r theta dot theta cap. But remember one important thing. When I do the derivative, that means here remember I cap, j cap are constant, but r cap, theta cap are not constant. If you look to the formula of r cap, j cap, then this r cap depend upon theta, and this theta cap also depend upon theta. So, but theta is the variable because we are doing plane polar. If you are doing the circular coordinate system, then your r will be constant, but theta is the variable, right? So theta is the variable. So when you do the derivative, so what will be you obtain? So you do the first derivative. I remember this is the velocity that we obtain in the plane polar coordinate system. So if you do the derivative, then what will you obtain you? That is the d by dt of r dot r cap plus d by dt of r theta dot theta cap, right? So this one you will obtain. Then do the derivative. That will be r double dot, because one dot is there. Then you do the second derivative, that is we represented by double dot, into r cap plus r dot d r cap by dt. Then plus this is UVW formula. So what you obtain? R dot theta cap plus r theta double dot theta cap plus r theta dot d by dt of theta cap. Then you know the r cap value. What is r cap? What is theta cap? What is, okay, r cap, theta cap you know. Do the time derivative. Then there will come, what is r cap actually? What we obtain? We obtain r cap as your cos theta I cap, then sin theta j cap, right? So we obtain this thing. You do the time derivative, that will be minus sin theta theta dot, and that will be cos theta, cos theta theta dot. But remember, this is cos theta I cap and this is sin theta j cap. So you have to again change the I cap and j cap into r cap and theta cap. So what I am telling that when you need this thing, d I cap by dt and d theta cap by dt. You need these two things. So when you do the derivative, so that will become you minus sin theta theta dot. Okay, minus sin theta theta dot, and next one will be cos theta theta dot. Okay, but remember this is minus sin theta theta dot I cap plus cos theta theta dot j cap. Then again substitute that I cap j cap in terms of r cap and theta cap. Then you will obtain the derivative in terms of r cap and the theta cap only. So you will obtain the acceleration. Okay, so try to do the acceleration. I am already told this. So remember this derivative you will obtain in terms of I cap and j cap, because the I cap is in I cap and j cap format. So you do the derivative in I cap j cap, then substitute this I cap j cap into r cap theta cap. That will give you the total acceleration. Okay, so you do this because this is the text for you. Do the acceleration and find out what is the final answer, and I will tell you the final answer in the next class. Still now you do this in your own. So these are all about your plane polar coordinate system, and in the next class we will discuss about the cylindrical coordinate system. Okay, so if anything, if any trouble or any mistake, please comment in the comment section. And if you like this video, then please give a big like and share it so that it will be reached to all others. And also please subscribe the channel. Okay, so share it to the others and subscribe, that is important. So click the bell also to get the new notification, so it will be helpful to others also. Okay, so share it. Anyway, if any mistake, please comment. So this is all about for today, that is plane polar coordinate system. Okay, thank you. Jai Jagannath. Keep watching and keep loving physics. Thank you.